Good afternoon, everybody, and welcome to the December CEA Power Hour. We've been doing these now for 6 months, I think, and it's really interesting to have a technical theme this time. I'm Joanna Oliver. Normally I'm looking after the international programs for the CEA. I should be overseas doing exhibitions and trade missions. Obviously I've been grounded since Conexpo this year, so I've taken on running more of the online events, and also I get the fabulous job of being the government liaison person. So I've added Brexit and COVID to my job specification. So as you can imagine, that's much nicer than spending my time in Chile and South Africa. Not. So just quickly, we'll run through the rules of the CEA House. Most importantly, this webinar is run in accordance with the CEA corporate compliance rules, and that's really important that nobody says anything out of turn, particularly anything to do with competition. You will be quickly removed if you do. The webinar will be recorded, and it will be available to anybody who's participated in today's webinar, and also it will be on the CEA website with the presentations from today's speakers. Please stay on mute unless you're actually asking a question, and there will be opportunities at the end. But we would ask you, if you do want to ask a question, to write it in the chat box so we can look at who's asking what questions. If time allows, we will ask you to ask the question in person. If we're running short of time, I'll just read them out and the speakers can answer. Please turn off your video unless you're actually asking a question. I know some people have issues with bandwidth, so to help all of us have good connection, please turn the video off. And finally, if anything goes wrong, it's not our fault. Well, it might be, but I don't think it is. And everybody has technical difficulties now and then with Zoom, but we will do our best to make everything run smoothly. So, today's speakers, we have a really good, I think, presentation today, because it meets all the current buzzwords of digital AI, machine learning, and most importantly, collaboration between manufacturers. I'm going to call now on Gavin Robertson from Husco, who's going to introduce the rest of his team. Gavin started his career in engineering, working in industrial hydraulics, and then moved into the world of mobile hydraulics, working in sales and marketing for Husco. Gavin's got over 30 years of experience in the industry and works as Director of Sales and Marketing for Husco International in the UK, and he looks after Europe, Turkey and Russia. So I am now going to stop sharing my screen. Oops. And let Gavin take over.
Okay, well, thank you very much, Joanna, for the introduction, and of course the invitation to the CEA Power Hour today. I'd contacted Joanna and the CEA team really to see if we could present and showcase the synergies that you can generate when you get two expert companies working together in a way that they can share that expertise based upon having a mutual goal. So as Joanna mentioned, and as I'm sure you're all very much aware, machine automation and driver assist systems are very much the hot topic within the industry today, and that's for a multitude of reasons, health and safety being just one of those. So what we have today is that Husco and Leica Geosystems, which Leica Geosystems is part of the Hexagon group, we've teamed up to share the hydraulic controls knowledge and expertise that we have in terms of machines digging and the know-how that we have and have developed within Husco, and then share that really with the expertise that the Hexagon group have with autonomous controls, and surveying expertise, so that we could get together and develop a high-performing machine solution that's particularly applicable for excavation applications as well as other machine applications. So we're hoping that the presentation that we're going to make today you'll find of interest, and it'll be thought-provoking in a good way, and that at the end of the presentations we'll be able to have some discussion and questions to go through with you. So without further delay, I'd like to introduce the speakers. So from the Hexagon Geosystems group, we have Hoppy. Hoppy's going to give you an overview of the big picture in terms of how the industry's been changing, the way it works really, and the way they're integrating now with more sophisticated surveying and automation systems. So Hoppy's got a wealth of global experience, and amongst his other achievements, he's actually the chairman of the digital task force for CC. So he has a lot of experience in the area. But I guess more importantly than that, Hoppy is now an adopted Scouser. He's a German guy who lives in Liverpool. So like our famous Jurgen Klopp, the football manager, Hoppy's now living in the UK. He actually lives not far from myself down the road in Liverpool. So he's picked the right city to live in, so that's a good thing. So after Hoppy's made his presentation, he'll then be handing over to Simon and Ben. And Simon and Ben are going to give you the hydraulic story behind our presentation. So basically, we're going to explain to you how hydraulic systems have been adapted so that they're more precisely calibrated with software and electro-hydraulic controls to support the drive and the move towards machine automation. So Simon and Ben have both worked for Husco for about 10 years now. Simon's more focused on the business development side, and then Ben is really our in-house guru who looks after the software and controls that convert electrical inputs into essentially the digger output, so the digging end of the machine. Ben spent a lot of time developing specialist software algorithms to make that happen, so that we can offer a very highly precise precision control machine with a combination of the Hexagon Geosystems components linked in with the Husco control software and know-how and components. So after the two presentations have been gone through, obviously we'd like to open it up for questions, and we hope that you'll have some interesting questions for us to answer. So without further delay, I think I shall, as I say, pass over to our adopted Scouser, Hoppy, who's going to take us through the first part of the presentation.
Well, thank you, Gavin. That was so my being adopted is better than me being able to scouse this way through. So, yeah, thank you for having me. As you said, you know, I've been with Hexagon for some time now. And but I think in terms of introducing this whole theme, what I wanted to do is zoom out just a little bit in terms of what's actually happening in the construction industry. What does it mean to the end users, the contractors? How does their challenge and impact a lot of the audience today in terms of representing OEMs? And then ultimately, what does it mean for folks like us, you know, that kind of sit at the end of this value chain to a large degree. So Simon, if you just flip on to the next slide. So here is pretty much, and I think most of us probably by now have read the same McKinsey report that tells us, you know, how bad construction is as compared to manufacturing in terms of adopting technology. And so I have my own views on this in terms of it's easier to digitize a factory where you can just close the doors and switch on the air conditioning. But we do see some changes. We do see some changes happening in the construction industry. We do see increasing digitization, rapid digitization in some cases. We see more industrial approaches to building just in time, information flowing up and down, and the various actors in the supply chain. You know, we probably all heard about houses being 3D printed now, but I've also seen pavements being printed, walls being printed along highways. I think that's a technology that is rapidly coming. And we all know that there is ongoing pressure, continuous pressure in terms of cost and the quantity and quality of skills in this industry, which has almost been epidemic. Now that has an impact on the people that make money, should make money in construction. So we see obviously still the same pressure on them delivering on time, on spec, on budget, increasingly on safety, luckily. But what we also see is, to a degree, them trying to catch up with the regulations, and probably the biggest topic that I hear frequently is the challenges to find people, keep the people, but also make sure that their workforce kind of gets introduced to the right technologies, and make sure that people stick with these technologies in terms of something that enriches their jobs, that is something that allows themselves to grow. But workforce acceptance of technology is something I hear frequently as an issue being brought up by our customers. And so then, as an OEM, how do you play in this dynamic environment? Well, increasingly we see that there is a certain stickiness to these technologies. So contractors, just us, like being Android people or Apple people, you know, once customers adopt certain technologies, they like to kind of expand based upon their learning of these platforms. We see OEMs themselves having to have a very significantly larger and different talent pool. And we compete for the same talent in a lot of cases, and we compete with people like Google. So you can see that, you know, this is getting tight. OEMs need to understand, okay, where do I want to be proprietary? Where do I want to be open? That's a frequent challenge. And then the next one is, okay, with a customer base that is not 100% I want to have machine control, or 100% I want to have this and that. How do you figure that out as you take the order? You know, is this something you want to do in the aftermarket? Is this something that you want to do in the factory? So there are some challenges here as well that OEMs face. Us, we're operating in all of these markets. We provide technologies to contractors. We provide technologies to OEMs. And we like to think of this as being an agnostic game. We love all of our children. We love all of our partners. We love Husco. But in the end of it, I think there is more to be gained by all of us growing together as compared to going after one another. This is an industry that will change, and it will change quickly. Next slide, please, Simon. So who's Hexagon? Biggest brand you ever heard of? Never heard of? But really what we like to see ourselves is being in that next phase of digitization. I would say the first 10 years of this century were connecting people to the ecosystem. The second 10 years were about connecting objects to the ecosystem. Now we got to connect the rest of the planet. So we can connect objects, people, everything into a digitized landscape. So cars don't crash into buildings. Machines kind of grade soil nicely, and we make sure that this digitization across the various players happens. That's pretty much where we act overall as Hexagon. My heart is in this next area here. So I do very much in the heavy construction space, and for us it means we really connect everything from the original design and capturing of the landscape. This is where we find our Leica brand, obviously, a surveying brand. Then things move into an office where people break down a project into the M's. M's being, you know, the months, how much money, how much manpower, which machines, which material. We then move into the connected site. That means making all of the elements on this site geospatially aware. Including the machines, the people, the material. We then get into the actual construction. I think then most of our focus will be on that today. And then obviously in the last phase, somebody will need to take care of the roads, the bridges, and the beautiful infrastructure that has been built over generations. So with that I want to finish here. It gives you a quick overflow of our portfolio and you know, the various pieces that need to come together to make geospatial reality a reality. You saw a few of this equipment operating here in the video, but I think from a technology point of view, one we found particularly challenging is the excavator, because the extremities of an excavator compared to its base are more mobile than on many other pieces of equipment. So as we geolocate a bucket towards the center of the machine, towards the actual material we want to move, is one thing, but then we actually need to get that movement done. And that requires hydraulics, that requires strength, that requires expertise in making sure that the right piece moves to the right location at the right precision and the right time. And so with that, I actually want to hand it over to our experts in this area, my friends from Husco, and give us a little bit of insight in terms of, okay, it's all nice, Hoppy, knowing where everything is, but how do we move it? And Simon, I pass it over to you. I think it's going to be a very nice part of this presentation. Thank you.
Perfect. Thank you very much, Hoppy. Yeah, we like being called experts. I'm not sure if it's true of me, but certainly is of Ben, but no, that's great. Yeah, and thank you for the excellent overview of the digital landscape. And that's a landscape that is available today, which is, yeah, really great to see the progression that's going on around us. The benefits of digital operation on certain machines, that's been actually recognized for some time. We've been using electro-hydraulic control systems for the blade control of bulldozers or motor graders for some time now, and that was very quickly we were able to achieve a lot better productivity through increasing precision, so less cuts required, or by actually increasing the speed required, because it's less operator doing fine adjustments but making some of those operations semi-autonomous. So we knew there was bringing in digital aspects and communicating with the digital landscape can bring huge benefits. But then we came to the excavator, and as Hoppy just alluded to, even from a surveying and a machine control, a large environment point of view, the excavator is difficult. Well, for us trying to control that, it's even more difficult. Excavators are really interesting because they've been, since their conception, they have been tuned year after year to make a skilled operator more productive. And so Husco really needed to develop what was represented by that box I have in the middle of the graphic here. We need a communication system, or a hydraulic API as we call it, that can coordinate the various human, we believe the human is still going to be in the cab, but digital inputs, start overlaying some semi-autonomous functionality, all in a precise and repeatable way. Your software engineers do not want hysteresis or variability or poor control. How to wrap that up, that was the real challenge that we had. But control of the excavator itself is really difficult, and we tried to kind of represent this. So if you imagine drawing a perfect circle with your hand, just a pen on a paper, or even worse, doing it on a wall with your arm stretched out, it's really complicated, and there's a lot of things going on in your head to control the various different muscles that are moving the pen or the paintbrush. Let's now translate that to an excavator where you have two hands doing all the control. This is our medium skilled operator. It's actually myself trying to draw a circle with an excavator, and it's really difficult. There's so much going on around the machine, the variability in the different geometry and the speeds, and that's, you need really skilled operators, and as Hoppy mentioned, that's something we don't have as many of now. So Husco's challenge was take an existing excavator and really dig deeper into the challenges that are available. So we took this machine, a standard rental machine in the USA, to come up with a solution to answer some of these questions and create that hydraulic API. The solution had to be safe, first and foremost, when it comes to any form of automation or overriding of a system. Had to be easy to install, although we are hydraulics guys and we could have completely ripped out the whole system and put a new one in, that isn't going to be feasible in the market. But most importantly, it had to be able to provide precise digital control of any excavator. So you don't want to have to tune one of these excavators for a week each time. It's unfeasible in the market. So Ben, who led up the team who did this work, he's going to walk through a few of those technical challenges that we faced. He's going to summarize the system that we developed, and he's also going to show you some of the results that we got all off this machine. So Ben, with that, I'll hand it over to yourself.
Thanks, Simon. So talking about the challenges of excavators, right here what we have is real data from a machine. For those of you that maybe don't know, hydraulics are extremely power dense. And so an excavator, a typical 20-ton excavator, has 2 pumps. One of these shown in the red and one of these shown in the blue. This is real grading, digging data, and it's got quite a trend. If you kind of pick out in your eye, there's a lot of points right on an edge, and you might wonder, well, why is there these edges here on this data, or why is there a lot of data in one certain spot? And what it comes down to is the hydraulics have a lot more power than what the engine can give, and this is because in some points you need a lot of pressure. You need a lot of force on the system to dig through some heavy dirt, or maybe you hit a rock. And so that's that top curve. That's where you're on the pressure limit of the system. Other times you're in free air. You're just trying to get the dirt out, spoiled to the right, or just get rid of it. And that's where you're on the flow limit of the system. You don't need much force. You just need to move quickly to get something out of the way. And then where you spend a lot of time while you're grading or digging is where you're on the power limit, where you're actually risking killing the engine because you're taking so much power out of the engine, and the hydraulics have more power to give, but you're actually limited because of that power. And so here you're on the power limit. And so this is a piecewise function. It's multiple constraints. All the while, the operator is commanding full sticks to try and make sure that they're going as fast as possible. So during a dig, an operator is actually cognizing in their mind how to traverse through these pressure, power, and flow limits while they're disassociated, while they're further away from what the actual machine would be doing in single function, or if they're hitting a rock, or if they're in free air. And so all the while, real time, an operator, while they're digging, is meandering through these curves, trying to make sure that the machine is doing what it needs to be doing, all while trying to be productive and efficient. And that's something that takes years, if not decades, of expertise to really understand and really get that muscle memory. And so that way the end effector, that bucket tip, is an extension of an expert operator's mind. And so this is one of the troubles that we have, is how do you train a computer system how to traverse through these curves? You can't just say, work at this limit or work at this point, because the environment is what tells you you need more pressure, or you're allowed to have more flow, or you're at the limit of the machine. And so this is one of the things that you have to think about while you're trying to control an excavator or many other hydraulic machines, is how to traverse through these limits successfully and not burn too much power, or not end up in an uncontrollable region because of it. All the while, I mentioned at the beginning that you have 2 pumps. If anybody's seen an excavator, you don't have 2 functions. And so over the last many decades, maybe almost even a century, the excavator has been tuned by the likes of Husco and others and OEMs in order to make it an extension of that operator. And what they've done that with two pumps. Now, some excavators may have up to 12 functions, or maybe even more, but generally just to do a simple grade, no tilt bucket, no tilt rotator, no aux flow, just a simple grade. You can see here in this animation, there's 3 functions that are actually moving. So if you've got 3 functions, but 2 pumps, how do you think that you would want to move those functions? And that's one of the things that the hydraulic main control valve has been tuned for these many decades on, is how to make 2 power sources work for 3, 4, 5, sometimes 7 functions in order to get some coordinated movement. And because of that, everything interacts. It's a pressure flow based system in the hydraulics, and each function interacts. So if the bucket hits a rock, it's going to add pressure to the arm to try and dig through it, which is then maybe going to push flow to the boom, and you'll lift up. Again, the operator real time is doing a closed loop control in their brain to adjust for all of these minor nuances, all these minor changes in the system, because they know what's going to happen. This all has to be programmed into a controller in order to make a grade possible. So that way it is flat, accurate, repeatable, and not jumpy all over the place. So how do we do this? One of the ways we do this, one of the things that we do is a general person. If you think about how fast you move, you might move about 3 times a second, right? If you're chanting at a football match, how fast do you rock your arm? It's maybe about 3 hertz, so 3 times a second. So what I've got here is a graph where frequencies on the x-axis, and if you look at this top graph, the speed is on the y-axis. So something I like to do is take our minds out into the washroom and look at the washing machine. So natural frequencies, this omega n, this wn that I'm showing here, is where you can excite the system where it actually goes unstable. So if we look at our washing machine, every time you go through a spin cycle, it kind of goes slowly, and then you get this thump, 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 and then it speeds through that and goes faster and then gets quiet again. And so that thump, 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 thump is where the natural frequency of the system is. And that's where you're most excitable. So if you think about the spin cycle, where do you dry the clothes the fastest? That's where it's at the fastest speed when it's out past the natural frequency. Do you still dry the clothes below the natural frequency? Yes, but it's not as effective. It's not as productive. It's not as efficient. Do you want to sit at the natural frequency of the system where you're just constantly going thump, 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 thump? Going at the natural frequency, you're going to end up breaking things because you're you're exciting the system. And so if we look at that similar sort of thing here, we've taken real data again from a conventional mobile hydraulic hardware. This has been tuned for an operator, so it's about running at 3 hertz. So if you look where the horizontal dotted line meets one of those dots, it's somewhere in between the boom natural frequency and the arm natural frequency. So generally, our hydraulic system is operating about the speed of what the boom can handle. So it's about where you excite the boom the most, and it's a little bit higher than the machine natural frequency. For those of you who have driven an excavator, if you notice the boom, you can get the machine unstable, and the machine, you can get the machine unstable. And that's because conventional hydraulic hardware has a natural frequency that's about the frequency of the boom in the arm. Now, other machines, you see that the arm and the bucket generally are hard to go unstable. It's hard to get them to go fast enough. You always want the bucket to be a little bit harsher, or to dump out a little bit faster, or shake a little bit faster, so you can get that really clay, dirt, soil out of the bucket. But sometimes that's not possible depending on the machine, and that's because your hydraulics may not be fast enough to really excite that system. And so this is where you see the red line is where the hydraulics can actuate. It's maybe underperforming on the arm and bucket. It's not going to the apex of command. It's not going to the most productive, the fastest command. But it's driving right about where the boom natural frequency is. And this is why a lot of times when you start trying to control machines, you end up with an unstable machine, because the boom, just as soon as you touch the boom, it starts shaking the whole machine. And that's generally because of how hydraulics have been tuned and the natural frequency of the hydraulics. So I'll touch on this a little bit later, but I'd like to explain then what we did to try and improve the performance, improve the natural frequency, to alleviate some of these problems and some of the other challenges that we discussed in the previous slides. So the solution we developed, we're a hydraulics company. We make a lot of main control valves, a lot of EH valves, but we also have over the last several decades developed many control algorithms to showcase that EH hydraulic valves, electro-hydraulic valves, can and do operate just as good, if not better, than pilot systems. It's not the simplest, it's not the quickest, it takes a lot of know-how to do that. But we've been able to showcase to a lot of our customers that this is possible. And when we came and started working with Leica a little bit, we found out that having our know-how on a controller that's just accessible allows us to focus on the hydraulics, and allows Leica to really focus on the machine structure, the machine kinematics, the sensor chain. And so each of us took on our expertise and really made sure that they worked as best possible, so that way we had the best overall system in the end. So Leica just trusted us to work on the hydraulics and make sure that the hydraulics did what they're supposed to do. And so we ended up calling it this hydraulic API, because it was a programmer's interface for Leica to just get the hydraulics to work. They didn't have to worry about latency, response. other things because it was all taken into control in our controller. And so Leica could worry about the 3D mapping of the site, and Exacto would just work. And so we call this Exacto. Really, the goal of this was to make an easy, integrated, turnkey subsystem that gave anybody access to existing machine hydraulics. So if you had an existing pilot-operated machine, you could install this quickly, as Simon said, and start using the machine as a robot without having to have any underlying hydraulic knowledge. And we did this through putting our electrohydraulic control algorithms onto this controller. And with the integrated harness, you just plug in one connector and you're ready to go. And then we also developed, again, as safety is important, we developed with the partners a functional safety routine to make sure that we can comply to all the European directives, to make sure that not only is this a integrated and simple system to make the hydraulics work, it was also safe in accordance with what we deemed and our and Leica deemed necessary. And so we're just about finishing up that documentation here before the end of the year, and we'll be able to claim this as a functionally safe system in the end to be for sale in the market through Leica. And so now coming back to our data here, with the Exacto system, we said that we want to make sure that we're able to control at the absolute performance of the system. And so with Exacto, we're able to push out the natural frequency of the hydraulic system out past 10 hertz. So 10 times a second, we can switch direction on the hydraulics, which you might say is a lot for an excavator. But when you're talking about moving the bucket or talking about moving the arm quickly or precisely, making those minute changes to be ultimately accurate on the grade, you need that performance. You need a higher performing control system than what your plant is doing. So we wanted to make sure that we had the hydraulics that had a faster reaction time, not only in latency, but also in a reduction of amplitude that was out past the bucket natural frequency. And we were able to achieve that. And the next couple videos that we'll show showcase when you have a precise, fast, repeatable hydraulic system, what is possible when you join that with robotic machines such as an excavator and building information management tools, the 3D management of existing work sites. It really does turn a existing machine into a CNC machine you'd see on a machining floor. And so the results before we get to the videos are here. So we have a intended bucket position, if you look on the bottom graph, that we want a straight flat line. That's a goal for a grade. You can do other things such as a circle, as Simon showed, but for this showcase, we had a grade. And so if you look at bucket position, we're going through time. So left is where you would start on the grade, and then you'd pull that in, going to the right. And so we wanted a flat bucket position. And then if you look, in order to get a flat bucket position, you have to go through reverse kinematics and the linkage structures to understand what velocity do you actually want on the system. And that gives us the second graph. So we've got a commanded velocity in the solid lines, and then an actual achieved velocity here in the dotted lines. And then if you look at your pilot pressures, ultimately that's what the hydraulic system needs. That's what Exacto gives as a pilot pressure to the main control valve. We've got a pilot pressure that's requested and then an actual pilot command. So any deviations from the command versus the actual is going to give problems that are going to propagate out to the bucket tip position. And so as you can see here, we've got a full grade that we've done in, it starts at about 2 seconds to 7 seconds, a full grade that we've done in 5 seconds here on this proof of concept machine, all within 25 millimeters, plus or minus 25 millimeters of the requested grade. And that's only able to do when you've got a highly reactive, precise hydraulic system that can be capable of making those minute adjustments as you go through the earth and come to unintended rocks or soft spots or hard spots that don't do exactly what you were hoping to when you go through that grade. And so these are really the results that can showcase what you can do with a really high performing repeatable hydraulic system.
Perfect. Thank you, Ben. Well, so in summary, the system, it really did, it kind of met our initial targets, the safety and the convenience of fitting this. Certainly in our lab in the US, but I know from hearing from the Leica guys, you know, fitting this complete system in under half a day is very easy, which is really good. And on the performance side, we really were able to achieve pretty much 90% of the available velocity of that machine. Since then, a bit more tuning has gone on, and we're actually able to exceed that. But that's really quite impressive, considering all those challenges and all those different variables that you have seen, and Ben has spoke. You know, we were really quite pleased with how that's gone. Since the initial work, we've increased the amount of functions that we can control and port through the controller as well to make it expandable, because that's pretty important. But I hear you all wondering, and Ben alluded to, what about that circle that Simon mentioned? Well, we removed me from the cabin. That was probably the first important thing we did. We used the path planning that we'd used for the flat grade, and we plugged that into the Exacto system, and here was the result. So a lot better than, unfortunately, I could ever achieve. But the headline here wasn't really about the performance, although we were very proud of what we did. It was the fact that it then opened up Husco, this hydraulic control valve manufacturer, the ability to partner with companies such as Leica and integrate into their infrastructure and all of their environments that we have seen. And this working in partnership that we have mentioned today, that really shows when you look at the components. Leica have a great suite of communication, human interface, sensors, and more importantly, the machine control software. They have that whole suite, but just not that final piece, which was the integration into the hydraulic system on the excavator. And so here we can see one of the Leica techs actually fitting the Exacto system onto a Kobelco machine that we'll be able to show you moving soon. But that was what was really important for us. And this unit has been fit to over 30 different machines in the last 12 months. And the real strength of this partnership is showing me is that not one of those various different machines, different makes and models, has had to have different hydraulic tuning. So the work that Ben has done on all of that consistency and how we've worked with Leica on the communication means that you don't have to put it on and then tune it for 4, 5, 8 hours to get it correct. It's always working like any correct API to anything that's demanded by the user. So that's been a real important part, and that's why these partnerships have been so important. Getting this towards a semi-auto functionality, excuse me, that was the most important part for us and the aim of both companies. And early in October, this system was actually released to the market and has made it out onto several machines. And the release really sparked an important step, not only just for both companies, but it was a really good step forward in productivity and bridging the gap to challenges as highlighted by Hopi with construction today. But also it showed that in-depth technical requirement that's there that both companies have had to kind of overcome together, which Ben mentioned. So that's made it really great for me personally, being part of the project with both companies and using both strengths. But before the Q&A session, I've got one more quick video, which is actually from the field. This field you see here, digging this very complex shape, just to show you both companies and both systems working together. So from me, thank you very much for listening. I look forward to some Q&A, and now I'll just get the video to fire.
Today I'm sat in a Kobelco SK210 that's recently been installed with our semi-automatic system. So it's got the standard 3D machine control from Leica that's now on the MC1 platform, but on top of that it's now got a valve fitted that allows the operator to have hydraulic control of the excavator through the machine control system. Okay, so let me just talk a little bit about the functionality of the system, talk you through some of the components that we've got on here. The first thing we've got is the same panel that we'd have on a normal 3D excavator system. So you have your cut fills for either side of your bucket. You've got your design here for, in this case, a swale pond. On top of that, we now have the option to auto prepare some of the functions of the machine, so we can take control of the boom, of the bucket, of the tilt, and also the rotation, because on this particular machine we've got an SMP tilt rotator as well. So we have hydraulic control of all those components, and what that means for the operator is the only thing he has to do is pull on this lever and the machine will automatically grade to the design. So that's what we've got on the system and some of the bits there for the operator. I'm now going to show you some of the components elsewhere on the machine. So the first thing you'll notice is up here on the handrail we've got our GPS antennas, so they're picking up the GPS signals throughout the day. That signal is then sent to the ICG82, which is placed just here, and that does all the calculations involved with the GPS, including any RTK corrections, so that we get our sort of 20-30 mil accuracy there. And you'll also notice we'll have sensors placed on different parts, so each moving part essentially of the excavator will need a sensor to read the angle. So we've got our boom sensor up there. We have got a body sensor mounted inside the slew ring as well. You can see just up here we have a sensor on the dipper arm. There'll also be a sensor inside the hitch for the bucket angle. And then for this SMP tilt rotator you also need an extra sensor for the tilt, which is placed just inside the unit there. The way the tilt rotator works is for the rotation we get a value from the SMP system by interfacing directly with them, and that's how we get the accurate results for any movement of the machine essentially. So that's it for me. We've spent the past couple of weeks getting our first semi-automated excavator here on site, and it's now ready to dig away at this swale pond.
Okay, that's it from our side. Thank you very much, as I mentioned, for watching. Really interesting, and yeah, we really welcome any questions.
Thanks, everybody. That was fascinating. I mean, I'm totally not an engineer, but even I can understand how revolutionary all this semi-automation and then presumably full automation is going to be. I just got a quick question, while hopefully other people are going to be writing things in the chat box. So come on, guys, we've got 12 minutes. Please make use of the time to ask some questions. But at PlantWorks last year, we had a drone zone with drones in construction. Presumably, there's going to be quite a lot of drones used in the surveying and collecting the data. And does your equipment talk to the drones, or do people need to get specific software to pair up with the drones? How does that all work? Oh, you're all on mute.
Yeah, Hopi, I think that's probably for yours.
Yeah. I just wondered, like, how is Simon going to answer that one? So look, yes, excellent question. I think as it comes to surveying aside, you know, today we see like three major ways of doing this. One is aerial, that's drones. You have the typical terrestrial. Those are the good old surveyors you still see around, standing in the countryside, holding their gear. And then increasingly also we find underground radar to actually be able to map, you know, what is under the surface in terms of pipes, in terms of cables. So all of this data typically today, yes, gets digitized. It gets aggregated in a, you know, some people call it a digital twin of the site, you know, a digital reflection of the landscape. And once you have that, yes, you can translate that into maps that are understood by machines. So the machine then knows, okay, here is not only where I am and where my hand is, but here is the actual material that I have to move. And so in that case, then this information would be fed into the machine. And then after the work also, you can do that same drone flight again and see, okay, how much material have I actually moved? So we see a lot of the integration of the technologies. We see a lot of the integration of the information as it flows through various pieces of equipment. And we also see more integration of the players in the various companies that provide these services.
Okay, thanks, Hopi. Okay, we've got a question from Peter Haddock. What do you think the market in the UK would be units-wise, and what type of business are you expecting to take this on? And also, how does the Husco team see the development of its solution moving forward in the next 2 to 3 years?
I can certainly take the second question. It's a bit easier for me. So, as Ben mentioned, we have a huge history in electro-hydraulic solutions, and for us, when we did a lot of the initial work, it was how can we use our own control software to build that in our main control valves. You know, Husco provides 99% of every product that we produce goes directly to an OEM, the John Deere's, Caterpillars, JCBs of this world. We don't serve the aftermarket at all, really. So it was, how do we develop that technology and build that into our main control valves, because that's ultimately the solution that will be in the market. But then in the work that we've done with Leica and others, how the benefit that has come and the ability for the end users like Plant Force, like we saw in that video, they want the technology now, faster than the OEMs can develop, or faster than people can actually physically get everything together. So this is where the relationship kind of started with Leica. And so I think that is actually going to run as a business itself for some time. So for all of the machines that are currently out there, there's a lot of stress on capital utilization. So if it comes on a brand new excavator, you don't want to have to spend £200,000 on a brand new one to get this feature if you already have that capital investment there and you can just upgrade it by putting an aftermarket kit. So I believe that there is probably between 5 to 10 years that upgrading older systems is probably the way to go. And once you've made that switch, as I hope we mentioned, when you've moved to Apple, when you've moved to Android, once you've made that switch towards a full electro-hydraulic machine, which we can enable, then it becomes more of a software or human interface. It's other parts that get developed and move everything forward rather than the actual system itself and changing the hydraulics. That's where it starts to become quite interesting, that your features are not brought on by adding more flow or adding a different hydraulic section. It's actually the software and the sensors that become the development path, which is slightly easier to upgrade. So that's our point. Joanna, you'll have to repeat the first part of the question for me.
Yeah, what do you think the market in the UK would be units wise, and what type of businesses are you expecting to take this on?
Okay, so currently I would guess at total excavators in the say 20 to 40 ton, which I think is the key market. Anything above that is kind of mining, and anything below that isn't really used for mass excavations. Say that's between 500 and 1,000 excavators a year, maybe. That might be a shade high. I would think kind of 10 to 20% of those people are probably looking for smarter options, particularly owner operators, because they want to get out, they want to get more out of that machine. So they're always looking for ways to spend more money on that machine and get the best out of that capital that they have. And for companies like Plant Force, this is an extra service they can provide. So I could rent all those machines from this company, or I could rent one less from another company because they have this technology, and then it becomes a chargeable service for them. So yeah, I would say 10% probably of the UK market currently, I would imagine, maybe a little bit more. And obviously it's different in different regions. Working with Leica, their knowledge of the Northern Europe and the Scandinavian markets, this I believe is a very popular, or going to be a very popular option. Maybe not so much in the cost competitive Southern Europe and as we head east, but yeah, I'm hoping for around about 10% in the more developed markets. That's kind of our target.
Just to add to some of Simon's points there, from a strategic point of view, we do recognise how important it is to develop the expertise in hydraulic controls, electro-hydraulic controls, and the history that we've got in digging know-how from years and years of testing machines, data logging, we're realizing that, you know, it's really those controls in the future that are going to be the differentiator for the big hydraulic OEMs. And you know, you can see a future where you have some very simple control valves, but the software that's being used to control them is the differentiator. So we're recognizing that we need to get ahead of the curve in terms of our hydraulic controls know-how, and that goes hand in hand with having these digging algorithms that Ben and his group have been developing, and Husco's been developing for the past 20 years. So we do see this as okay, there may not be huge short-term sales in terms of number of units, but strategically it's the right thing to do.
Okay, one from Stephen Creaser now. Can the machine control data be imported from the machine into a fleet management platform via an API enabling it to be viewed remotely? Who wants to take that one on?
I have some thoughts on this. And so I think technically there is obviously a possibility, right? Data is data, you can get it on and off the machine. My thoughts though are, for what most fleet management systems today are designed to do, they are more interested in terms of, you know, how much usage has the machine been seen? What is the fuel consumption of this machine? How safe to a degree has the machine been operated, and what's its health condition? And from what I've seen today, there are excellent solutions from the majority of OEM that provide this with telematics that really can be aggregated in terms of, you know, how do I manage my fleet? Our key focus in Hexagon is the machine itself and how the machine interacts with the environment. That says, if somebody was interested in that data because the machine is not otherwise connected, I think this can be solved technically, but it's not necessarily the core focus of our business. Now, that being said, I think technically it's something that has been solved by a lot of OEMs. Now, if you would think of fleet management more in terms of what is the overall productivity, precision, accuracy in regards to have I built what I was supposed to be building, you know, then we get into areas where we would need to redefine fleet management as I know it. But yes, that is data obviously that could be shared, aggregated, analyzed, and manipulated in a variety of ways.
Okay, there's no more questions. We're coming up to the end of the power hour. So if I could take back the screen, great. Let's see. Okay. So firstly, thank you so much to the team from Husco and Leica Geosystems Hexagon, as I now have to say. That was a really in-depth, I think, demonstration of where we're going in the future. And I know these guys are really willing and ready to take your questions offline. There are contact details in the presentations. If anybody wants to do it straight away and you didn't write the emails down, just let us know and we'll put you in touch. If any other CEA members would like a similar opportunity to present a power hour in the future, the first opportunity we have is March. If you have an innovative product which you think is going to help the end user or other manufacturers in the supply chain, please send me an email and we can talk about making a presentation. So the next power hour in January is international trade post-transition period, which is really a follow-up to the November one that we did, but we're looking at the technical side, and this is going to be on the 20th of January, and it will be Dale Campsell, our senior technical consultant, and Malcolm Harbour, who's a former MEP and patron, and also was an engineer in the automotive sector. So it's looking at it from a regulatory point of view rather than just pure trade. And then February, we've got Sam Mottram from Caterpillar looking at the recovery, hopefully by then when the vaccine's kicking in, and the effects of the pandemic, mainly in the Americas, and also a bit of a more global outlook. So we'll be sending some invitations out to them. Any CEA members on the webinar, don't forget to register for our end of term report, Christmas and what happens in the new year, which is this Thursday between 3 and 4. We'll be opening some windows on the CEA Advent calendar and having some messages from some of our directors, our chief executive, and some other people. So I think that's it. That's all, folks. Thank you very much for attending. We'll get the presentation up on the website as soon as we possibly can. If anybody's got any questions in the meantime, just drop me an email. And thank you very much for attending. Thanks, guys. Bye-bye.